Welcome to Flotilla Update 32, which is a little video tour of 4 of the final Flotilla modules, and we're going to take you through the features, have a look at them, and kind of, I guess, discuss what they can be used for.
Yeah, a bit more in depth, so talking about what's on there and how it functions and project ideas, really.
Hopefully something to whet your appetite for when your Flotilla arrives. Should we start with touch?
Yeah. Okay, first up, touch.
So the touch board is capacitive touch, and I believe the sensitivity can be tweaked, which would allow it to also operate underneath a sheet of material.
Kind
or
of
something,
behind
nice.
a front plate or something to that effect. If you're mounting it in a project and you want to label up the buttons to be something other than 1, 2, 3 and 4, then you'll be able to do that.
In the meantime, we've just got 4 buttons there, numbered from 1 to 4, and a chip that turns those buttons into commands over I2C back to the Flotilla dock. As with all Flotilla boards, it's got 2 mounting holes or more in the corners. This one's got 2 M3 mounting holes. They're the same kind of size as we use on Pybo, so the same bolts will fix it to most stuff.
You don't generally press it very hard, so two mounting holes are more than enough.
Because it's quite thin as well.
Yeah.
And you can also use things like cable ties in those mounting holes. Works really well.
Each of the buttons has got an LED indicator above it, which can either indicate the state of the button, so whether you've got it held down or not, or they can be controlled independently as well. So you might do something like a Simon Says game, have the LED turn on, press the button to clear it, which is nice. I think you can also control the brightness of the LEDs.
Within reason, yeah, the chip will allow you to control the brightness of all the LEDs together, but not independently, because it's strange like that. It will, by default, allow you to fade the LEDs in and out. So when you touch a button, it will do a nice little fading effect because it looks good.
Like a little pulse. And this is ideal basically for anything that you want kind of touch input on. So maybe controlling a robot up, down, left, right, doing like a keypad entry code.
Yeah, just games, things like that. So multiple choice questions.
Oh, this would be really cool with a
point,
dock and like 4 people with these on long cables, and then have a quiz game on the. Right, we should totally make that happen.
But
like a quiz game where you each answer the question.
Pie quiz. Multiple choice questions about pie.
There we go. You can take things too far. tragically dull. Yeah, but that would be a really cool thing. You could have this as like your. So say you built an alarm entry thing for your bedroom or whatever. You could have this keypad as your code entry, so you can go in without triggering the alarm. There's a lot of useful things you can do with that. I think the original button module on Flotilla was just a single button. It was a tactile switch, but we just didn't think it wasn't that
It had
interesting.
the RGB LED on it though. It's a very weird kind of combination, and then, like you said, it felt like those two things were.
We started off with just the button, and because of the way Flotilla works, we need to have a microcontroller to turn that button input into something the dock and Pi can understand. Which made it feel a bit pricey for what it was.
Yeah, for just a tactile switch, it didn't seem like it would be good value.
Because we're trying to keep Flotilla affordable and feel like really good value. And we added the RGB LED, but as Phil says, it felt like a Franken module then, which it was okay. But
I still like it though. I still feel it could make a comeback.
It could make a comeback, but
there's a lot to be said for a tactile button.
At the end, the value proposition was to have 4 capacitive touch buttons with LEDs that you could do stuff with. Because they're very useful, very popular, and we can make it very clear like this. It's just there as a useful component. We're going to use it in the instrument kit, so you can use that to program in notes or program in sequences. Phil's just working on that right now. Before I left New York, I laser cut something, stuck a load of modules to it haphazardly, and threw it at Phil and said, "Make that awesome." And he will.
And he did, actually.
Yeah.
It's pretty cool.
It's kind of experimental jazz generator at the moment.
Right. Yeah, that's okay. It's a good start.
It is. So that's the touch module. It's going to be dead handy. It's a really useful little thing to have. It's a good part of the system. Next up, we're going to have a look at the barometer and pressure sensor. This is using a chip called the BMP280. The BMP180, which was the predecessor, has been around for quite a long time, and you'll see it on Adafruit breakouts, Sparfun breakouts. It was really popular with hobbyists for like a reasonably priced, quite accurate barometer module. The BMP280 came out while we were developing Flotilla, so we upgraded to that. This is just a great module for doing things like weather station projects.
Yeah. Now, in common with the other sensor modules, they have a little highlighted bit on top there where the sensor is, so you can get an idea of where the reading is being taken, which is that white flowery bit. That's actually a little cloud because it's barometer weather type stuff.
It's so cute.
Yeah, and this module will give you both the atmospheric pressure and the ambient temperature. So you can use it to work out altitude, you can use it just to monitor temperature, you could use it to like trigger when it's too warm and you might need to water the plants or something. I mean,
Yeah, you should be able to do some basic
Just
kind of
kinda
weather
cool.
station type stuff with that as well.
yeah.
Yeah, if the
Quite
pressure's dropping massively, then expect bad weather. That kind of thing. Yeah. Again, it's got the mounting holes, the M3 mounting holes. So a mini cable tie will attach that to things very easily. Although putting it out in the wet is probably not the best idea.
Have
No.
we got another small round module to demonstrate that? I've got one here, but it's not one of the ones. Just to demonstrate that the mounting holes we put on these, on the small modules at least, are all kind of aligned with each
Close
other.
up.
So that if you go to the lengths to create a mounting for one of the small sensor modules, then they should all fit.
Yeah, they all have consistent.
Doing a really
mounting
bad
holes.
job of showing that, but
Yeah,
there you go.
trying to line them up. as fit.
Yeah, those little round modules all have the same basic dimensions and layouts.
Yeah, so that's. I mean, that's again, it's a cool module. It's amazing that you can buy sensors that do this kind of stuff.
Did we link the layout guide?
The layout guide? No,
Yeah.
not yet.
Okay, we've got a layout guide that will show all the modules with where their mounting holes are. So if you want to plan your own little teaching thing or project, you can do that with that and use it to say, well, the dock goes here, that goes there, and the motor goes here.
And that basically has the outline dimensions for every module. It has the mounting hole positions, where the USB connector is.
Yep.
So kind of all the information you need to laser cut your own kind of mounting plates or whatever.
Or 3D print or whatever.
Yeah, 3D printed.
And it's essential info for hacking around with the modules, really.
Okay.
Yep.
And next up, we'll have a look at Rainbow Stick. This has gone through a couple of iterations actually. We've settled on a design that essentially uses the same chip that our PiGlow add-on for the Raspberry Pi uses. This is 5 RGB LEDs. They're fully controllable and it's really nice for creating kind of mood lighting effects. We used it to underlight our little robot buggy when we were down in Leicester at Creator Fair.
Oh, that was so bright.
It was
that was
really
the prototype module, and it was insanely bright. So
It's kind of cool. We actually got the LEDs frosted so that they're slightly less aggressive than normal kind of 50-50 style LEDs.
it gives them a better colour mix on
Yeah.
low
Blends
brightness
it,
as
yeah.
well, which is
So
really nice.
more even colour.
And other than that, I mean, it's just a cool stick. We did it with 5 pixels specifically so that you could use it for things like have a central point. So to the right could be player 1 winning in a game, or to the left could be player 2, or you can run a dot like a metronome on the instrument. There's all
Yeah.
sorts of things you can do with that.
Or
Which
if
is
you do
pretty
some
cool.
kind of spirit level with the motion chip as well.
Oh yeah, with the accelerometer.
That's
Yeah.
Yeah,
I
you
tried
could do
that.
that.
That's a
Yeah.
good point.
Because if you've got 6, then you never have an LED that's dead centre. Whereas this way you do.
Wow,
Yeah,
wow.
so it's a very specific design choice to go for 5 LEDs.
We did start this one out of a microcontroller as well, didn't we? But I realised in retrospect that we had exactly the right chip for the job.
Yeah, originally it was used. Well, the reason that we avoided the PiGlow chip originally is that it doesn't support multiple I2C addresses, and we were going to have that chip on the dock, which kind of complicated things a bit. But in the end, we didn't use that chip on the dock, which freed up the address, so we used it on one of the modules instead. Yeah, the microcontroller version used WS2812Bs, which actually don't look as nice because they don't have we haven't got the frosted version of that, and yeah, it's just a nice thing. It's great for doing mood lighting and stuff. So yeah, it should be a good module, that one.
Yeah.
Super nice.
Cool.
Show me
Great
that.
little indicator. Okay.
And next up, we have probably the most exciting module, which is the motor, and the one that we spent the most time working on.
Apart from the dock.
Well, apart from the dock
Oh,
itself.
module
yeah.
wise, yeah. Yeah.
So the interesting things here, I guess, are the shape of the PCB itself. We went through quite a lot of iterations, and it was pretty early on we realised that the deeper that PCB is, the bigger any buggy you make has to be, because you'll obviously have one motor and then another one backing onto it on the other side of the chassis. So our first versions of this, they didn't look big PCBs, but all the components were kind of behind the motor, and it just meant that robots had to be at least 20 centimetres wide, which didn't seem very flexible.
Mm.
It was
So we kind
routing
of
the
spread it
cables
out.
out as well, because actually getting them to do a very tight curve was tricky. So when you put 2 of them opposite each other, the cables would
Yeah, they matched into each other, didn't they?
Yeah.
So what we did is we offset the cable. There's a little is actually on the edge, which means when you put a reversed motor on the other side, the cables come out at opposite ends of the module, so that they don't clash into each other. You get better routing away. We also recessed it as far as we could, just to get, it's only another 5mm or so, but it just means they can just be a little bit closer, which makes it more flexible.
Let's go to the close-up again, take a look at the wheel as well. Because the bits involved in this, and a lot of this is, one, getting good bits, and two, getting it down to a reasonable cost. Because when we started out, motors and wheels and everything, we just had to sell them for too much, and we thought there must be a better way.
Yeah.
I think having this, which is a motor driver, the motor itself, a bracket to hold it, a good wheel to go on it, which mounts nicely and has a grippy tyre.
Yeah.
We've got all of that together, and we're hoping that'll be, a very useful thing.
Yeah, we actually the motor driver on here is an H bridge, which means that you can control the motor in both directions. It's also one that sports kind of PWM speed control, so you've got full control over the speed of the motor. We made a custom motor bracket for it, mostly to match the colouring of the Flotilla module, just so it sits in there nicely. And we found these wheels which are kind of moon buggy-esque, which we kind of like.
Grippy,
and they're really grippy, aren't they? The rubber is super kind of tacky and grippy on surfaces.
And if you want a gear that will mesh with anything, you can take the tyre off and just use the raw wheel on its own.
Yeah, we should work out what the gearing on that is.
Yeah, definitely.
Yeah.
We could do another diagram
Start
for that,
counting.
Actually.
I should be able to cut gears to interface with it.
I think other than the dock, the motor is by far the most complicated thing, just because of the number of different parts we've had to either source or go out and create. It's been interesting.
Yeah, but all the work on that is why we ended up with the kind of really cute buggy that you saw a couple of updates ago.
Yeah.
Yeah, so we're very happy with
You
that.
can't beat that purple and orange combo.
No, it's really cool.
It's unmissable.
It's a critical module, really, isn't it? Because it's no fun if you can't make a buggy of some sort.
Yeah.
I would say the disco robot went down fantastically well at Leicester. There were loads of kids who were content to sit there for ages just with a slider that made the robot do nothing but drive forwards and backwards, no steering or anything, and just play with the disco robot.
Right.
And then you could connect a dial and have someone else control the hue of the lighting.
I liked it when we had it hooked up with the accelerometer, so that the tilt of the accelerometer drove the wheels, and just watching kids try to figure out how to tilt it just to get it to go forwards or change the speed.
That was for steering as well. So there was a certain angle at which it would stop, and then a certain angle you could turn left, and then a certain angle you could turn right. And
was this all Rockpool again?
That was all in Rockpool,
you were live coding and it worked.
So
that's amazing.
For once we're doing live demos, live everything, it was working really beautifully well, and with the Pi touchscreen as well.
Okay.
Yeah.
Interface needs some tweaks, but you can touch and get your way around everything.
Yeah.
Really nice.
Because me and Phil kind of worked it up a certain way, and then you played with it and said, these things don't work. It needs to work this way to be really clear. And this is the process we're going through now. Yeah, just to hone it, to get the user experience right, so that it really is as easy as it can be. You can't go wrong with it, and it all makes sense that you know how to add rules and edit things. And it's a really easy intro to working with Flotilla.
Yeah, and these, we should point out that these are all basically production samples of these modules. So they are completely locked down, PCB colours are finalised, all the parts are either with us or on order right now. And we're currently going through the kind of 10% production batch at the moment to make sure that everything goes smoothly. But it seems to be going well.
There are a lot of these sitting around at the moment.
There are a lot of touch modules.
I tried to line them all up for a photo and just got tired after the first dozen.
And we're going to do another couple of video updates with like 4 modules each, so there'll be 3 in total, including this one. So the next time we'll pick 3 more modules and kind of talk through those, and
yeah,
that's where it's at right now.
Yeah. Any other news? I think we're waiting for a doc this week, aren't we? Final doc with fiducials.
Yep.
We finally got it all right. That'll be nice.
Well, that means we'll be able to make up a full panel of docs, test the process, test the stencils, which will be nice. And then, assuming that goes all right, we'll be ordering the actual PCBs for the docs. So we'll be very, very close at that point.
Yeah.
Which will be excellent.
Mm-hmm.
I think that's it.
Right.
See you later.
Bye-bye.